Okay, good morning, everybody. Just a quick announcement. Assignment 2 was posted last night. So if you're ready to work on assignment 2, you can get started on it. You'll need some of the information from today's lecture and obviously from the next lecture or two in order to complete it, to complete the entire assignment. But you can definitely get started on it after today's lecture. Right, so we were talking about, I was introducing the different types of expansions to you. We're going to look at most of these expansions in greater detail in a separate notebook. But for now, I just want to show you what the different expansions are. So we saw a brace expansion that lets you generate some strings using a simple pattern. Tilde expansion we've seen before. All right, so remember the tilde symbol, that expands to the name of your home directory by default. Right? It's possible to change what that expands to, but normally it'll expand to, unless you change it, it expands to the name of your home directory. Right? So when you write something like echo and then tilde, right, the shell replaces the tilde with the name of your home directory. Right? So remember, every expansion or substitution, that's exactly what happens. The shell looks at the thing that's called an expansion or substitution, performs the expansion or substitution, and replaces the result, and uses the resulting text to replace the expansion. Right? So that tilde literally gets replaced with the name of my home directory. And so that ends up printing my home directory. If there's multiple users on the system, which you won't probably have on your home computers, then you can also use tilde followed by the username, and that will expand to, what is this? This is probably giving me a funny result here. Okay, so that will expand to the name of that user's directory. So in this case, this is a bad example because there is no CISC220 user on this computer. So this is expanding to the string tilde CISC220. But let me show you something else. So I'm currently logged into the computing science. There's a server there that people use for research purposes. You can see there's a bazillion users. So I'm in the home root home. You can see there's a lot of users here. Right? I'm way at the top, so I'm not going to go all the way there. You can see that some of the users' home directories, they are accessible to everybody. Right? So whoever RMRISK is, I don't know who that is. It's probably some undergraduate or graduate student. Right? You can see that world, right, or everybody else has read and execute permission on their directory, RMRIZK. So I can switch into their directory, even though I'm not that user. Sorry, CD, RM, there we go. Right, so I can enter that directory and look at what's there. I'm not going to look at what's there because there might be something that I shouldn't be looking at. Right, but if I echo, there we go. Right, so there you go. So if you use tilde in front of a valid username, right, that expands to the home directory of that user. Right, so tilde RMRIZK expands to that directory there, which is the actual home directory on our particular system that's used in computing. Right. Now, if there is no user with that name on this particular computer, right, then the expansion doesn't work. Right? So this tilde does not expand in this case. Right? So if it can't find the user CISC220, right, then tilde CISC220 does not expand. Right? And so you end up with just tilde CISC220 as the string. Right? So this was not a great example. There's no way for me to write this example in a notebook. If you change this to your directory name, it'll expand correctly. So for example, if I change this to that and run it now, right now it expands properly. That's another one of the confusing things that happen to you that can happen in Bash. Right? If you're expecting the user, some user, to exist on this system, right, then you would expect that this expansion should work and give you the correct home directory. Right? It would be nice if some user did not exist on this computer, that this expansion doesn't work and you get an error message, but you don't. Right? Instead, the expansion doesn't happen and you get the string tilde some user, which is super annoying. Right? So for example, if I try to cd tilde some user, right, it's not until you try to use the expansion for something that you end up realizing that there's a mistake. Right? So the fact that this does not expand when some user doesn't exist can lead to hard to find errors. So you have to be a little bit careful about this. Okay, there's something called parameter expansion. This is basically how do you use a variable in Bash. You can do lots of weird things with variables in Bash. So we'll look at that in a separate notebook. All variables in Bash are essentially strings. So parameter expansion covers all of the things that you can do with strings in Bash as well. Right, so there's a whole notebook dedicated to this. It's called strings. Wait, it's called, there's two of them actually. There's, is it just strings? No, it's just strings, right? Variables and strings. Those two notebooks will cover parameter expansion. Okay, command substitution. So command substitution is neat. So in Bash, you can run a command, right? And that command will produce some output, right? If you want to use that output, if you want to use the text of that output for some reason, right, then you can capture that text using what's called the command substitution. Right? So the way command substitution looks is you write a $sign, right? You write a round bracket, right? There's a closing round bracket, and inside the round brackets, there's your command, right? So what happens here is that when Bash encounters this when you're typing this into a Bash script, or if you're typing this in on the command line, when Bash sees this construct, right, it launches a separate shell. So it launches what's called a subshell, right? It runs the command in that subshell. Right? Whatever output that command produces gets captured, and all of this gets replaced with the output of the command that ran in the subshell. And then the subshell goes away. So let's look at this date command. So I'm going to write date plus %a. I think if you're on a Mac, this gives you different output. So date, what the heck am I writing? Date plus %a. Date plus %a. Okay, so that prints out the day of the week, the current day for today. Right. I also have date plus %h colon %m. Date plus %h colon %m. Right, that gives you the current time, that gives you the current hour and minute, right, of the, for today, right? Oh, okay, so if I want to print out the string, today is the current day, comma, it's the current time, right? Then what I want is I want to run the date command to get the current day, and I want to run the date command to get the current time, right? And I want to capture the output of those commands and substitute those outputs into this string, right? And that's exactly what a command substitution is for. So when Bash sees this command here, right? It sees that there's an echo command. It sees that there's a string, right? That echo should print. Inside the string, right? It sees a command substitution. Right? So it launches the subshell, runs date plus %a in the subshell, grabs that output, and replaces everything I've highlighted with the output of date plus %a. Right? It sees a second command substitution, right? And so it does the same thing. Launches a subshell, right? Runs date plus %h colon %m, grabs that output, substitutes it for everything that's highlighted. Right? That results in one big string, which I guess for today is Thursday, and it's 9:05. Right? So the output of those two date commands, they get substituted into the string, and then that string gets printed by echo. Right? If you want to, you can take the output of a command and stash it in a variable somewhere. So I haven't told you about variables yet, but they exist in Bash. So I can make a variable called moo, right? And I can assign it the value of whatever that is. Right? So again, it's a command substitution, so $round bracket. So run the cow say command with the string moo, right? That runs in the subshell somewhere, right? Prints a cow with a saying the word moo, right? And that result gets stored in the variable mu, right? So mu is just a big string, right? So if you run it, nothing happens, right? No output here, right? So the output of the CalSave program is captured and stored in the variable, right? It doesn't get output. Later on, you can use the mu variable and print out the output from the previous command, right? So if you want to store the result of a command, you can use command substitution to capture the output from that command. Right? I'll tell you what the $ means either later today or in the next lecture. Okay, so that's a command substitution. There's also what's called arithmetic expansion. So you can do simple arithmetic in bash, but it's limited to integer arithmetic. So there's no floating point arithmetic in bash. If you need to do floating point operations, you have to use an external program to do so. But it's unusual. It's quite unusual to have to do floating point arithmetic in the bash shell. Even integer arithmetic, the shell is not really designed to do arithmetic, right? That's not really its purpose. Its purpose is to interact with the operating system. So yes, you can do integer arithmetic in the shell, but you're not going to do anything that's, well, you typically won't do anything that requires a lot of arithmetic. Right? So if you need to do some arithmetic, then it looks like the following. Notice that it looks a lot like a command substitution. Right? So command substitution, it's one round bracket, it's one pair of parentheses with a $ in front. An arithmetic expansion, it's a nested pair of parentheses, $ in front. The spacing is important. There can't be a space between these two brackets. So there's no space anywhere in here. There's no space anywhere in here. For an arithmetic expansion, spaces inside the innermost round brackets don't matter. I wonder if I change this. I'm going to change this back for a second. I don't know what this is supposed to be because I ran this notebook previously. All right, so here we've got $ round bracket, and then 0 plus 7 inside, right? So we have a simple arithmetic expression inside, right? Not surprisingly, well, perhaps not surprisingly, right? That prints the number 7, right? You can do multiplication as well. And remember, everything is integer. Everything is integer arithmetic. So we can multiply, right? You can divide. Right? So that's going to give you 0 because this is truncating division, right? Works the same way as in Java. 1 divided by 7 is 0 point something, throw away the point something. You can do division subtraction, obviously. So there are negative numbers, that's fine. Right? You can do exponentiation in bash, right? Which you cannot do in Java. So the exponentiation operator is ***, right? Similar to Python, right? So that's 8. Right? Of course, you can use parentheses to specify the order of operations. I believe that's it. Oh, there's remainder. You can do remainder. So 4 remainder, no, let's do 5 remainder 2, right? That's going to give you 1, right? So remainder works as well. And I think that's it. I'm pretty sure that's it, right? So you've got your 6 arithmetic operators. Right? Now, why would you want to do this? Well, normally you wouldn't. It's unusual to want to do this. Right? So the only time you'd want to do this is if you're computing some file name, and the file name contains a number in it that you can compute for some reason. Right? This is a dumb example here. I'm going to make a directory. I'm going to change it to 3 because I think I already have that directory. Right? So I'm going to use an arithmetic expansion here to compute the number 15. Right? Now remember, what does an expansion do? Well, bash evaluates the result of the expansion and then replaces everything that's highlighted with the value. Right? So there's an arithmetic expansion. It's equal to 15. Right? So you end up making the directory dir 15. Right? And if I run that, somewhere in here there's a dir 15. Let me there it is right there. Right? Now notice this looks weird, right? So if you're used to some other programming language like Python or Java, this is very strange, right? This looks like it shouldn't work at all, but it does work, right? And so the reason it works is because that's the way bash works, right? You've got an expansion of some kind here. Bash evaluates the expansion, replaces it with whatever text was there. right? So even though that looks strange, right, that actually is the way that the bash language works. Okay, so they are somewhat uncommon, right? Especially if you're working on the command line, right? It would be very unusual to be working on the command line and typing something in, and typing in some arithmetic expression. They are occasionally, this says frequently, I don't think that's true. They are occasionally used in a script, right? Okay, finally, I think this is finally, word splitting. No, not finally. Well, we've seen file name expansion before. Okay, so there's something in bash called word splitting. So after all of those expansions that have been described so far in the notebook occur, right? Anything that's not inside double quotes, right? So you have to remember that, right? If it's not inside double quotes, right, then that stuff undergoes what's called word splitting, right? So word splitting just takes the string. Wherever there's a white space, it splits the string into those separate substrings. Right? So word splitting splits a string into what are called parts or separate parts or fields. Right? Each field is delimited by space around it. Right? And what ends up happening is you end up with a list of string. Right? Just a space-separated list of strings. Okay, so how does bash do word splitting? Well, it looks for white space. Right, so by default, white space is defined as a space character, a tab character, or a new line character. You can actually change how bash does the splitting, which is also occasionally useful. Right, and so if you have spaces in names of files, that causes problems. Right, we saw that in a previous lecture. Right. Sorry, again, this was done. I ran this notebook earlier. Right? So if you have a folder called a file called CISC220 assignment solutions.zip, right? If you try to unzip the contents of that file like that, right? We've seen before that this doesn't work, right? Why doesn't it work? Because bash sees a bunch of strings that are not inside double quotes, right? So it thinks that these are all separate arguments to the command, right? So this is bash thinks that you are asking unzip to unzip that file, and that file. Sorry, and that file. Right? It doesn't think that you want to unzip the file CISC220 assignment solutions.zip. Right? If you run that, right, what does it say? It says I can't find any of those three files. Sorry, I can't find CISC220.zip, CISC220, CISC220.zip, or CISC220.bigzip. Right? So that doesn't work. Right? If you want to use if you want to use a file name with spaces in it, right, you have to indicate somehow that those spaces are important in that string, right? So either double quote the entire string or escape the spaces. So you can change the way that bash does the word splitting, and you do that by changing the symbols that bash uses to separate words. So a variable in bash called IFS, which is the internal field separator variable, right? It stores the current set of separator characters. Right? So by default, it's space, tab, and new line. Right? So any character that's inside of IFS, right, is considered to be a valid field separator. Right? If you have multiple spaces or multiple characters in the separator that appear at the same time, so one beside each other, then the shell just groups them all together and considers them to be one separator character. Okay, so word splitting occurs after all other expansions except for file name expansion. Right? So after file name expansion happens, word splitting doesn't occur. Right? Okay, so this can result in very strange results. Okay, so here we've got string, right? String's just a string, so it's inside double quotes. Right? Remember, the double quotes, they will preserve the meaning of most unusual characters in bash. Right? So all of these spaces here, those are preserved. All of these spaces here are preserved. The new line characters that are here, which you can't see, right? Those are all preserved in the string. Okay. So if I want to use the variable string, right, so I want to print out the contents of string, I have to write something like $string, right, like that. Right. So again, I'll explain what the dollar means in a separate notebook. And I think I want to get rid of these double quotes, like that. Right, now remember, so when I write $string, I'm performing what's called a parameter substitution. Right? And so what's going to happen here is that bash is going to look at the value of the variable called string, right, and substitute its value into for all of this. Right? And so what you want to happen, probably, is for bash to take all of that and stick it into here. Right? So if you try it, did I run this one? Oh, I didn't run this one, sorry. Oh, I guess I should point that out too. Notice that I didn't run this cell up here, right, before running the next cell. So when I ran this next cell, right, there is no variable called str. Right? In any other sane programming language, you would get a warning saying there is no variable called str. In bash, you get no warning, and it just prints the empty string. It also creates the variable str for you. So I'll explain all of that in the next lecture. Okay, so let me run this cell first. Let me run this cell next. Right, notice what happens. All of your words, all of your nice spacing, it gets destroyed. Right? Why does it get destroyed? Because word splitting happens after parameter substitution happens. Right? So when you take all of this, substitute it into here, right? The next thing bash does before using that string is perform word splitting. Right? So it takes all of those spaces, replaces it with one space. It takes all of those spaces, replaces it with one space. It takes all of these new lines, replaces it with one space, and you end up getting that. Right? If you want to preserve the literal value of str, of the string str, you have to double quote it. Right? And now it works the way you want it to. So very occasionally, it's useful to change how bash does word splitting. Right? So if you've got some string that has some character that's used to separate values in the string, then you can change the value of IFS and have bash split that string for you using word splitting. Right? So here I've got the string. I guess this is a student number, last name, first name. Right? So we've got the student polyester 1, 2, 3, 4, 5, 6. Right? If I would like to extract the individual pieces of this string, one way to do it is to say, hey, bash, please use the comma as your field separator. Right? And so the way you do that is as follows. Right? So what I'm going to do is I'm going to, yeah, question.
When you restart your shell, will it go back to the default instance?
Yes. Yeah, if you open a new shell, it comes back with, it will reinitialize the shell, yes. Okay, so here I'm going to temporarily change the value of IFS. Right, so the way I'm going to do that is I'm going to remember the current value of IFS. Right, so I'm going to make a variable called old IFS. I'm going to store the value of IFS in that variable. Right, I'm now going to change the value of IFS to be the comma. Right, and so this will cause bash to now split any words. This will now cause bash to perform word splitting using the comma as the separator. Right. So if I now print out str without quotes around it, right? So no quotes means bash will do the word splitting. Right? When it does the word splitting, it replaces all the separator characters with individual spaces. Right? Now you get out the string with the spaces instead of the commas. Right? After you change IFS, you should probably set it back. Right? So once I've changed IFS to do the word splitting with a comma, it's usually a good idea to switch it back to make sure that word splitting happens in the normal way. So don't forget that last line there. We haven't looked at loops yet, but this is what one type of loop looks like in bash. Right, so it's the same example. This time I want to process each individual field separately. Right, so I want to process the student number, then I want to process the last name, then the first name. Right, when I process them, I'm just going to use a little loop. Right there, there's your parameter substitution. It's not quoted, so bash will do word splitting on that parameter. Right, so in other words, it's going to give you back the 3 strings, 1, 2, 3, 4, 5, 6, Esther, and Polly. Right, and so if you run that, you get the separate parts of the string all on one line. Right, of course, you can change what's inside the for loop, or you can do something else here instead of a for loop and process the parts of the the split string separately. Right, and we'll look more at this later in the course. Right. Okay, so there turns out there's a lot of rules that actually specify exactly how word splitting behaves. We're not so concerned about the precise rules. Right? All you need to remember for this course is that it happens, right? And you have to be aware that it can happen. So if you're programming up some script somewhere and you start to see strange results, right? Like you're seeing multiple things that shouldn't be there, you're probably a victim of word splitting, right? And so don't forget, you probably have to double quote the thing that you're trying to use, right? If you want to know more about the exact words, about the exact rules, you can click on that link, right? And find out all the gory details. Okay, so file name expansion we saw before, right? So file name expansion, remember that's when you use a star or a question mark or the square brackets with some symbols inside, right? And those will all perform expansions that match file names, right? Those happen last, right? So it's important that if you expand a file name that has spaces in it, for example, right? That word splitting doesn't happen on that file name. Right? And that's why file expansion happens after word splitting. Right? That's why it's the last thing to happen. Right? So the order in which the expansions occur, they are defined in that order for a reason. Right? And so it's usually you don't have to remember exactly what order things are happening in, right? But occasionally occasionally you're going to run into a bug that's caused by the fact that the expansions are happening in a particular order and you thinking they're happening in some other order. All right, so that's a quick introduction to the various expansions in bash. Again, we're going to look at all of these, most of these in greater detail as we go through the course. All right, so we're on to the next notebook. So your next assignment, you're going to be writing what are called a bash script. Right? So a bash script, so you know, like, so far I've been showing you, you type stuff in on the command line, right? Press enter and something happens. You can instead write those commands in a file, right? And you can put all those, put in as many commands as you like, right? And then you can run the file as though it were a sequence of commands that you typed in directly to into your terminal, right? And so a shell script is just a sequence of commands in a file somewhere that you run as a program. There's a few things that you must remember. Right, so number one, if you want to run your script in the normal way, right, then your script file has to be readable. Right? So you need read permission on the file. You also probably want execute permission on the file so you can treat it as a regular program. Right? So that's number one. Number two, the vast majority of you will have never been affected by this. Right? But this is going to affect you now in the course. Right? So when you're using your operating system through a graphical user interface, right, whoever created the software that's running on that you've installed on your operating system, they've taken care of this next step for you somehow. Right? When you're writing scripts in bash, this problem is not, when you're writing scripts on a Unix-like operating system, this problem is not solved for you. So when you run a command via the command line, or when you double-click something as an icon on your operating system, right? When your operating system tries to run that file, it needs to know where that file is on your operating system. Right? So commands like ls or unzip or zip or something like that, right? They all typically live in the directory root bin, right? So there's zip, right? Remember ls is here too, right? So ls root, sorry, bin ls, right? So ls is there as well, right? And so the reason this directory exists is because it's a common place known to the operating system where executable programs live. So in Linux, one of the directories that are searched by default for commands is root bin. Right? Now, when you're writing scripts, you're not going to be putting them into root bin, right? They're going to be in one of your directories somewhere, right? Probably in your sys220 assignment directory somewhere. Your operating system by default will not search that directory for the location of that file, right? So when you go to run your scripts, you're going to have to run them in a special way, which I will show you shortly. Okay, so your scripts, they're just plain text, right? They don't have to have any special name. So you can name them whatever you want. Right? There's no universally accepted style for naming script files. Right? So in this course, though, any script file is always going to have the extension .sh. Right? You may not, this may not be the case in real life, right? But for our purposes, I'm always going to name them .sh so that you know they're a shell script. Right? I'm only going to use lowercase letters for the most part. I think for all parts, right? So I'm only going to use lowercase letters in the script names, and I might use numbers, and I might use the underscore, right? But that's it. Right? So I'm not going to use uppercase letters, and I'm not going to use unusual symbols. Definitely no spaces. Right? But in the real world, you may encounter those. You may encounter script names with unusual characters in them. All right, so everything, if you're following along, you can find all the scripts in that directory there. All right, so let me show you something else before I do all that. What did I call this? Hang on just a second here. My script. Okay, so I've got a file in here that I just made. So you don't have this file, right? So I've got a file here called my script. Inside my script, there's one line, right? And that one line is just a bash command. Right? So this is hello world in bash. Right? So I can run this file. Right? So I can run my script. Right? So notice my script has, right? So I can read and write that file. Everybody else can read that file as well. Right? So I don't have execute permission turned on with this file, right? Which is why it shows up in white and not green. Anything in green has execute permission turned on my particular terminal. Right? If I want to run the contents of my script as a bash script, I can type in the command bash. Right? Bash is just launches a bash shell. Right? And then I can pass in my script. Right? And then I can run the script like that. Right? So that runs. Right? And you get the string hello world. So that's one way to run a bash script. Right? It's not the normal way to run it, but it's one way to do it. Right? It's similar to running a Python program from the command line, right? To run a Python program from the command line, you can also type in Python and then the name of the Python module. Right? The way a normal bash script looks, it looks something like this. Right? So that's the same program written in the usual bash way. Right? In Jupyter, you can run this. Can you run this script? I don't know if you can run this script in Jupyter. Yes, it does run. Okay, so Jupyter can run a script. You should also be able to run this from the command line, and I'll show you how to do that in just a second. All right, so let's make this program the way it looks right there. Right? Okay, so at some point you need to install an editor in your, if you're using if you're using the Windows Linux subsystem, I think the instructions were install Visual Studio Code. If you're on a Mac, you can use whatever text editor you want, right? So I have code installed, so I'm just going to launch it. Let me just check if I have hello world here. I have hello.shell. What's there? Okay, so I'm going to remove hello.shell, and I'm just going to make a new. So the way I'm going to do this is I'm going to do the following. So you don't have to do it this way. You can just use code to create the file. So I'm going to make hello.shell by using touch. I'm now going to edit it with Visual Studio Code. So code is just called code, right? And that should start up. It may do something like this. We'll just give it a second. Okay, there we go. So Visual Studio Code pops up, and I'm going to, in a second, here we go. Oh, edit the contents of this file. Right. Okay, so normally the first line of a bash script looks like the following. Exclamation mark, hashtag exclamation mark. Root bin bash. I like that. I think. Exclamation, yes, root bin bash. Where'd code go? Okay, so that's what you should write if you're actually in Linux. If you're on a Mac, you want to write something else. So if you're on a Mac, it's user bin environment, I think. Let me check if I put it in the notebook. I did not. Okay. Where am I? Here? Yes. Oh. Oh, that's interesting. This didn't used to happen this way. Well, I guess this is a good time to point this out. If you start code, I thought that what normally happened is it ran, code starts up, and then you get your shell back. And notice I don't have my shell back. Right? If you run into this problem, what's happening is that the shell is waiting for Visual Studio Code to finish. Right? When Visual Studio Code finishes, I'll get the shell back. Right? So when you run a long-lived command in bash, right, the shell stops. The shell waits for the command to finish. Right? When you're running an interactive program like code, right, this may not stop for a long time. Yes, question. You don't want to run Control-C. So, well, I will do Control-C for you. If I type Control-C, code goes away. Oh, wait, code's supposed to go away. Code did not go away. That's not how you're supposed to do it. That's funny. This is hilarious. All right. So number one, so that's unusual. I didn't think code took away so what I thought happened is that code normally runs in the background. Is it still working? Hang on, let me just check to see if I can actually, oh, it is still working. That's fascinating. All right. What I wanted to tell you is that you can move that process into the background. Right? And so the way you would normally do this is you would type in Control-Z. Right? So that will take your long-living program and it will suspend it. Right? And then you can force it into the background by typing in the command background. But this apparently is not going to, that's not going to do it. Right? All right, so not such a good teachable moment. Never mind. Root, bin, bash. Oh, right. If you're on a Mac, I believe it's user bin environment. env, and then bash, I believe. Well, we'll try this in a second, see if it works. We'll figure out what the correct thing is for you in a minute. Right? The reason you don't want to write root. Let me explain what this does first, and then I'll explain why you want to do it the other way if you're on a Mac. Okay, so what this means if it's the first line, on the first line of your shell script, right? So what this means is this thing here, that the hashtag %sign. This is what's called a shell directive, right? Is that what it's? Somewhere I tell you what it is. There it is. Interpreter directive, that's what it's called. Right? So you want to start with that. Whatever is after it, right? So that thing there is the name of a program. Right? That program is going to be the name of the program that's used to interpret the rest of this file. Right? So what this is saying right here is use bash to interpret the contents of this file. Right? So now I'm going to use echo hello world, like that. Right? So there's my command. You save the file, right? So I've got it saved now. And now you come to your shell and you try to run your program. Right? So what I called it hello.shell. Right? And so what you would like to do is you'd like to type in hello.shell like that, right, to run your program, because it's the name of a command, right? Right there. Wait, which hello? This is funny because everything is not working the way it's supposed to work. Oh, that's why it's not working. Sorry. I have another version of hello shell. Sorry. Remove. This is really quite funny. Okay. All right, so what I want to do is I want to run hello shell like this, right? And that's what should happen, right? It should complain, right? There's no such file or directory, right? And you say, well, that's weird. It's right here, right? It's right here, right? Right in the directory I'm currently in. So the rule in Linux is that the current directory is not normally searched for any executable file. Right? So what you have to do is you have to tell it, I want to run the script that's in this directory. Right? And the way you do that is you pass in the name of the directory, right, before the name of the script. Right? So dot for the current directory, right? Backslash because I'm in a directory, and then the name of the script, hello.shell, like that. So that's the way you're going to normally run your scripts. Press enter, and it still doesn't work. Right? You say, well, that's weird. It says permission denied. Right? So if I list the permissions on hello.shell, right, you can see I have read permission, I have write permission, I do not have execute permission on this file. Right? In order to run a file as though it were a command, you need to set the execute permission on that file. Right? So I have to change mode. So I want to add execute permission for me. Right? So notice I now have execute permission. Right? If your shell has coloring turned on, it will normally show up in a different color. And now finally, I can run hello.shell, and now it works. Right? Okay, so don't forget you need to, number one, create your script. Right? You want to set execute permission and read permission if you don't have it on that script. Right? When you run the script, you need to tell it what directory are you in, or what directory is the script in. Right? So if you're in that directory, it's /name of the script, right? And then things will run. Okay, now let me see if I got it right for Mac. So I'm pretty sure it's user bin env, and then bash like that. Yes, I'm pretty sure that's right. Okay. So what that does is it says, use the program env to find the appropriate version of bash. Exactly what the appropriate version means is not important, right? But to use the appropriate version of bash on your computer. If you follow the instructions for setting up your computer, this will find the most recent version of bash that you installed, right? So it'll run bash 5 point something instead of what's installed on your operating system, which is bash 3 point something. Right? So if you're on a Mac, you want to do it that way. If you're in Linux, you can do it either way. Right? So whatever way you want to do should work. All right, what else do we want to do? You can put whatever you want in a script, right? So whatever command you want to run, you can put those commands in a script, right? So any valid bash command is also a valid line of a script, right? So if you want to, you can run the fortune program, pipe that output to cowsay, and have it print a moose that says the fortune. Right? So there's another example of a bash script, right? I don't know if this is here. Is it here? Fortune cow. So how do you run the script? /fortunecow.shell, right? And away you go, right? Right. Don't forget, you need execute permission on that file, right? So if you ever get the message permission denied, check the permission on the file, make sure that you have execute permission set for the file. Okay, so these scripts I've shown you so far are not particularly useful, right? So this one is slightly more useful, right? Notice that you have to do a bunch of things to get a bash shell script up and running, right? So it might be nice if you could create a command that automatically made a script for you and did all of the setting of permissions and stuff for you. So there's a shell script, right, that will create a file called temp.shell, right? When it creates the file, right, the first line of the file is the hashbang bin bash, right? So remember what that does, right? That prints that string, redirects the output to the file temp.shell, and then it changes the permission of that file so that it has execute permission turned on. Right? And so that will make an empty shell script for you. Now, of course, it only makes it it creates the name temp.shell, which isn't the most convenient. But we'll see how to fix that in a moment. Right? If I run this, right, you see nothing, right? You get no output, right? But if you go and look in the directory, there is a temp.shell, right? If you look at the permissions on temp.shell, right, you do in fact have execute permission on it, right? And if you look at the contents of temp.shell with cat, right, you can see that the first line of the shell is in fact hashbang bin bash. Right, so that's a slightly more useful shell program right there. All right, I guess that's a good place to stop. We'll pick the rest of this up on Monday.